It's time for our first real look into programming, and we will start with variables. Have a look at this formula. 1 plus 1. If I would ask you to calculate the result of this, you would tell me it's 2. And you would be right. How about this one? 1 plus x. You couldn't tell me the result, because addition only works between two numbers, not a number and a letter. X in this case is a variable, a placeholder that tells us where in this formula we have to put in a number. That means to calculate the result of this, you need additional information, namely, what value to use. I could tell you x is supposed to be 5, in which case you would insert a 5 and get a 6. Or I could tell you x should be a 6 and you would get a 7. This in a nutshell is how our programs will work. We write the formula that tells the computer what to do, but we will include some placeholders. The values for those placeholders are only determined once the program is running. It may be something you type in on your keyboard, or maybe it's the result of another calculation that needs to be done first. In any case, the computer will need some way to organize the different variables and their values. Let's try that on a new example. A plus b squared. Now we need two values for two different variables, a and b. And for that, we have a table. This table always has 3 columns and as many rows as we need. In the middle, we will put the names for our variables, so a and b. And on the right, we can insert their values, for example 2 and 14. To calculate, we can simply look up the values in our table now. A is a 2, so we insert a 2. And b is a 14, which means we insert a 14. That gets us 16 squared, which is 256. That seems to work pretty good already, so what is the first column for? To answer that, have a look at this. 1 over x. Again, x is a placeholder for which we can use any number. Well, not really any number. We can't divide by 0, so x can be any number except 0. Another example? Square root of x. This usually does not work for negative numbers. So again, we have to specify what x can be. Any number greater or equal to 0. These limitations are what we need to put in the first column. Although in case of Java, it's not about what numbers can and cannot be used. You see, in Java, the values we use can not only be numbers, but also things like text or images. Even the video you see right now can be used inside a program. This means we could easily run into situations where neither computer nor user know what to do. To prevent that from happening, we limit the type of value our placeholders stand for. In our examples, we only used numbers, and the most common form of that is an integer, so that's what we put in the first column. And because it's so common, the integer has a short name in Java: int. I think we should get some more practice with this, using a new example. Also, from now on, I will teach you a way to play computer yourself, because in my opinion, it's easier to learn programming if you understand how a computer would see your code. Don't worry, this won't get complicated. All you need is some paper and a pen. At the top of our paper, we'll put the table with our 3 variables. And below that, our example. I have some space restrictions here, so I'll put this sideways, but it's still the same thing. As a human, you would probably start by replacing all our variables by their proper values. As a computer, however, we'll only look up values when we absolutely need to. Instead, our first task is to analyze the formula and find out what operations we'll need to perform. We have 2 additions, 1 subtraction, and 1 multiplication. Since Java follows basic mathematical rules, multiplication has a higher priority than addition and subtraction, which means that is where we start, if it weren't for those brackets we have here. Everything inside them has automatically a higher priority than anything around. And since subtraction and addition are equal important, we simply go from left to right. So we have to start with 7 minus c, and therefore need to look up the value for c. In my case, that is a 3, which we will insert in the next line. 7 minus 3 is 4, and now we need to get 4 plus b. Looking up b gives us 2, 4 plus 2 is 6, and all that's left in the brackets now is a value. There are no more operations, so we can remove them. Multiplication has a higher priority than addition, which means we need the value for a. That gives us 6 times 5 equals 30, and looking up b again gives us still a 2, so we finally end up with 32. Everything we did in here can be broken down into 5 simple steps. First, we look at what operations we have. Then we determine which of those has the highest priority, because that's the one we need to focus on. If that operation involves variables, we need to look them up in our table before we perform the operation. And if afterwards there are still other operations left, go back to step 1. How about we bring this to the test on a real piece of program? This will also give us the chance to see how we can manipulate the values in our table. To do that, we need a second sheet of paper. The one we used so far, and which we will continue to use, is only for taking notes, to help us keep track of our variables and how far we are following a single instruction. The program code, however, the list of all instructions, will be put on the new paper. So what we have should look somewhat like this. 2 sheets of paper. On the left one, I'll put some code. Don't worry, just a few lines that you will understand soon enough, if not already. And on the right, nothing. When you start a program, that paper is actually empty. Our first goal will be to add something to it. A table for our variables. For that we need to know how many rows that table needs, or in other words, what is the highest amount of variables this program will have at any given time. In this case it's 3. So we draw a table with 3 columns for type, name and value, as established before, and 3 rows for up to 3 variables. That's all the preparation we need to make. Time to run this. When you look at the program on the left, you will notice that every line ends with a semicolon. That is because in Java it is a special marker that separates the code into single instructions. Therefore, our first instruction is int apples, which we will copy over to the right to work on. First step. What operations do we have? Only one, int, which, if you recall, is the short form for integer, which is a data type we can limit the values of our variables to. Starting an instruction with a data type is seen as an operation that creates a new variable with that type. So int is seen as an operation that creates a new integer variable. The word that follows that data type will be used as that variable's name. Since int is our only operation, we can skip step 2 and continue with 3. Are variables involved? No. Apples is just a name for the new variable, not a placeholder for which we need to look up a value. Step 4. Perform the operation. All we need to do is put int and apples in our table and we're done. No operations are left, so this instruction is finished. We can now remove our nodes, except for the table, and get the next one. Apples equals 10. What operations do we have here? Again, only one. Equals. Equals is an operation that changes the value we have assigned to a certain variable. The name of the variable we want to change is on its left side and the new value on its right. We only have this one operation and there are no variables we need to look up, so we can skip steps 2 and 3 again. Which means we simply look for the row with the variable called apples and change its value to 10. Now this instruction is finished as well. Time for the next one. Int boxes equals 2. This is exactly what it looks like. We have 2 instructions mashed together into one. Int boxes, which creates a new integer variable called boxes, and boxes equals 2, which changes the value for boxes to 2. But let's follow our 5 steps anyway. What operations do we have? Int and equals. Which has the higher priority? Int. Any variables we need to look up? No. So we create a new variable boxes and limit it to integers. Any operations left? Yes. So back to step 1. We only have equals left now. which therefore is the most important one. Nothing we need to look up, and performing the operation means setting the value for boxes to 2. And we're good. Next instruction. Int apples per box. You now know what that does. We simply create a new integer variable called apples per box. And now our final instruction, apples per box equals apples divided by boxes. One last time for today, let's follow our 5 steps. We have 2 operations, equals and division. Division has the higher priority. We need to look up the values for 2 placeholders, apples and boxes. We calculate 10 divided by 2, which is 5. Back to step 1. Equals is all that is left now, no placeholders to look up. Set the value for apples per box to 5, instruction finished, and since no instructions are left, the program is finished as well. Let's recap what we did today. You now know what variables are and how you can create, use, or manipulate them inside a program. This may not seem like much to you, but trust me, understanding this part is already worth a lot. Next time, we'll look into other data types Java knows and how you can create your own. Thanks for watching. See you next time.